Okay, so here's our Teensyduino, and I wanted to do a speed test on it. I have the LED number is pin number 13 hooked up to it's hooked to the LED light, and we have a scope probe here, and I'm going to just probe. You see pin number 13 there? Okay, and so anyway, this is our program here, our IDE, and it's the normal blinking IDE, but what I did is I took all the delays out and I'm doing a digital write. I'm just writing it high and writing it low. Now I know from past experience the digital write can be very slow, so I was curious about how this would perform, and there's a faster way to do the digital writes, and I'm going to try that in a second to compare. I just wanted to see this Teensyduino has a clock speed of 180 megahertz, so I was hoping we could get some really high performance out of it. With some of my Tesla coils, I want to use it for driving a Tesla coil, and some of the coils I have a resonant frequency of about 500 kilohertz, and so I was kind of surprised. It looks like the duty cycle on this guy is not equal, so the write high and the write low, or maybe it's the delay in the loop after it finishes, is not equal. And it looks like here, if we look at we put the cursors on there. Let me just stop the camera. Refocus. Okay, 820 kilohertz. But it's not a square wave, it's asymmetrical, so we would have to go at a much lower frequency to make it symmetrical. And so this is not the kind of performance that I'm looking for, so I'm going to try to replace these slow digital writes with a faster digital write, and we'll see if we can get higher performance out of our Teensyduino. Okay, so I changed the delay from 0 to the delay microsecond delay, and I'm just putting one microsecond delay in each instead of no delay. And it's starting to look a little bit more squarish, but it's still not completely square, and this is 309 kilohertz. Okay, 309 kilohertz, so still a little bit slower than what I was hoping for. So we'll try to do the fast digital write to compare that to see if we can get better performance out of this guy. Okay. Okay, so here we modified our program, and what we're using is the command ddrb, and 32 is this is basically in the setup telling you to set this to output for digital output. Now we're going to write directly to the ports, and you have to look up for the different chips. The different ports represent different pin numbers, and so it's different for every type of board, like the Uno or the Teensy. And it turns out that this one is pin 13, number 32, which is pin 5, I believe, B5, and because we're writing to port B, there's different ports, and different ports control different sets of pins, and so we're turning it on with 32 and then turning it off with a write to 0. So that's writing 32 is let's see, it's the 1s, 2s, 4s, 8s, 16, 32, so that's the 6th bit, which I guess represents pin 5. We're turning that bit on with writing 32 to that, and then writing zeros to all the bits. Okay, and here's our scope over here, and it looks like we're operating at about 446 kilohertz, which is about the same speed, maybe even a little bit slower than what we're doing with the digital write. So I thought we might get a little bit better, but there must be something internal to the Arduino Teensy here that prevents it from going any faster, which is kind of a shame. I'm going to have to look into that, and we'll see if we can figure out something. Okay, yeah, just for a quick comparison, on the same day I switched it back to digital writes again with no delay, and the pulse is very asymmetrical, but it is, we're measuring about 700 kilohertz, which is faster than the port write for some reason. Anyway, it's very interesting, so I'll take a look into this and see if we can do something useful with this. Okay, so I suspected that maybe the reason why it's running slow is because when you end a loop, there's a delay to start it over again. So I just copied digital writes on and off just as fast as I could for a burst. And let's see how fast we can go. And here we are on the oscilloscope, and it looks like we're able to switch up to about 2.84 megahertz at the very maximum. 2.84 megahertz, and that's on our Teensyduino here. Okay, so it might be something we can work with. Anyway, so here's the Teensyduino switching at 2.84 megahertz, and so this is Dr. Janes, and thanks for watching. Okay, so this is going to be a speed test for the Teensyduino, and here I have it hooked up to an oscilloscope, and we're going to show you how to switch it at 2.84 megahertz for the digital output, which is unbelievably fast for a PIC processor, Arduino type of unit. Okay.